Hello and welcome to this episode of Night Sky News for December 2025 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about what you should look out for in the night sky in the next few weeks, and then we chat about what's been happening in space news in the past few weeks. In this episode, we're chatting all about the deluge of observations released by NASA of Comet 3I Atlas after the government shutdown was ended, plus the most distant supernova and the most distant spiral galaxy ever detected by, you guessed it, JWST, and the largest rotating structure ever found in the universe. There's chapter markers down here if you want to skip ahead to any of those specific news stories, plus any research papers I mention are all going to be linked in the video description down below, free to read. So without any further ado, let's kick things off and start by looking up. All right, the big buzz this month is the close approach of Comet 3I Atlas, the interstellar visitor to our solar system, which makes its closest approach to Earth on the 19th of December. However, it will still be 270 million kilometers away, which is about 700 times the distance to the moon. So although you're probably going to see a lot of hype about this online, this is not something you're going to be able to see with your eyes alone or even binoculars, sadly. If you want to try and spot this one, you're going to need a telescope that's at least 30 centimeters, so 12 inches across, which is not exactly available to most people. So my advice for this one would be to look for events in your area, astronomy societies, observatories, that kind of thing that have that kind of kit and are maybe hosting a comet viewing party. Although another thing to note is that the best time to view the comet is going to be in the early hours of the morning because it's in the constellation of Leo, so it's not going to be the most convenient timing for heading out of the house for a stargazing party, especially if you've got kids as well. So something a bit easier for you all to spot this month, if you're lucky to have clear nights on Christmas Eve or Christmas Day, look out for the International Space Station passing over where you live. Because I give this warning every year to parents of children that the International Space Station moving across the sky can look very convincingly like Father Christmas's sleigh. It's incredibly bright and moves very fast, and I wouldn't want any children out there to confuse the International Space Station for Santa Claus. Now, thankfully, NASA have a really helpful app called Spot the Station that you can use to look up when the International Space Station will be passing over where you live, and it tells you which direction to look in, and you can even set reminders so you'll get a pop-up notification on your phone as well. For example, here in Oxford on Christmas Day at 6:17 in the morning, the International Space Station will appear first in the west, rise to almost overhead, and then set in the east a few minutes later. So if you're up that early, with or without kids, and it's clear, see if you can take a little peek through the curtains and spot Santa's sleigh. Sorry, the International Space Station. Then as we head into the new year, for those of us in the Northern Hemisphere, we've got another meteor shower to look forward to, the Quadrantids, and that peaks on the night of the 4th of January 2026, but you could see the odd shooting star from late December through to the 12th of January if you're out stargazing on a clear night. Now, in previous years, there have been up to 200 meteors per hour in the darkest of skies on the peak of the Quadrantids shower, so it is known to put on a show. It's predicted this year to be around about 120 meteors per hour on the evening of the 4th of January on the peak, so just over a shooting star per minute, at least in the darkest of skies. But the big problem this year is that the moon will be just past full on that night. And so it's just going to add a lot of light to the sky, reducing that number down that you can actually see. Plus it'll drop off even further depending on how much light pollution you have around you, which is just going to contribute to washing out the fainter shooting stars of the meteor shower. But since the predicted number on the peak is so high, it could still be worth trying to spot some shooting stars on the night of the 4th despite the brightness of the moon. So if you do fancy trying, the meteors will all appear to be streaking away from the handle of the plough or the Big Dipper. So you want to look anywhere but towards the plough to see these as they shoot away. So my advice would just be lay out a blanket, wrap up very warm, look directly up and enjoy the show. While you're there or at any point over the next few weeks, notice the gas giant planets of Jupiter and Saturn that are very bright in our skies at the moment as well. Saturn with its yellowish colour is off to the southwest, setting earlier and earlier as we head into January. Jupiter, which is the brightest thing in the sky sky after the moon at the minute is over in the southeast, right near the constellation of Orion in the winter hexagon that we spoke about last month. If you're not sure where to look, the almost half moon swings past Saturn on Boxing Day, the 26th of December, before sweeping around the sky to pass close to Jupiter as a full moon on the 3rd of January. Mars, Venus, and Mercury are all far too close to the sun from our perspective for us to be able to see them in the sky at the moment, but never fear, because Mercury and Venus will slowly come back to our evening skies as we head into the first few months of 2026. All right, that's it for looking up at the night sky for this month. Let's now come back down to Earth and chat about what's been happening in space news for this month. We've got to start by chatting about our interstellar visitor to the solar system again, Comet 3I Atlas, which we saw an absolute deluge of images released by NASA after the government shutdown in the US finally finished this past month. It was observed by NASA's Martian fleet as the comet made its closest approach to Mars back in October, which included Mars Reconnaissance Orbiter, images from MAVEN as well, and from the Perseverance rover on the ground on Mars. It was also observed by other satellites in the NASA fleet, like Lucy, which is a mission on its way to investigate the asteroids that trail Jupiter in its orbit, and also the satellites that we usually observe the sun with, so that included Punch, SOHO, and Stereo. Now, all of these observations are incredibly useful, even if the comet does just look like a fuzzy smudge in a lot of them, because you've got to remember how rare these interstellar objects really are. This is an object that has been formed in orbit around another star in our galaxy, and then has been ejected from that orbit around its star and has been traveling through the space between stars, interstellar space, ever since, until it happens to have passed through the solar system. There's only been 2 such objects found in the past. The first one, 1I, which was dubbed Oumuamua, was found back in 2017, and the second, 2I Borisov, was detected in 2019. So these are very rare objects. And we know that these are interstellar objects because their movements through the sky allow us to work out that their orbits aren't bound to the sun. They don't loop back around again. So this is why, since 3I Atlas was discovered back in July 2025, it has been all hands on deck to observe it as many times as possible with as many different observatories as possible. That's why we got another Hubble Space Telescope observation of 3I Atlas as well. It was actually an update from the observation it took back in July when the comet was further away. And you can see how in this new image, the Hubble Space Telescope actually tracked the comet as it moved across the sky so that the comet appears clear in the image, but the background stars are actually streaks because the telescope had to move with the comet. But with so much misinformation out there about Comet 3I Atlas, especially on the internet, which always likes to jump to aliens first, it means navigating clickbait headlines reporting on new observations of it becomes very difficult. Like this one that says the comet has woken up before approaching Earth as seen in a scary observation, or that ice volcanoes are erupting on the comet. Now, if these were the only headlines you saw without any other context, you might think the end is near, but the reality is that this comet, while a rare, mysterious interstellar visitor, it's still behaving exactly like we'd expect a comet to do. And unfortunately, this type of coverage isn't just limited to this story. It happens with multiple stories each and every day, and combing through all of these articles to find the truth is just an impossible task. That's where Ground News comes in, the sponsor I've been working with for a few years now. They're a website and an app designed to make reading the news easier and more data-driven. Every day, they pull in thousands of articles and arrange them by story, and each story comes with all the information you need to cut through the noise. So with Ground News, I can see straight away that more than 72 different news sources covered this story about Hubble once again observing 3I Atlas, with 90% of those sources having high factuality ratings. So within a few quick glances, I can tell this story is genuine. And not only can you directly compare headlines to see how the framing differs from source to source, I can even see what's being left out or framed specific ways using their bias comparison feature. It's data-driven tools like this from Ground News that make understanding and staying informed with the news so much easier, like their blind spot feed, which shows you which stories had little to no reporting on either side of the political spectrum. So if you head to the link in the video description below at ground.news/Dr. Becky or scan the QR code on screen, you'll save 40% off their Vantage plan to get unlimited access to all their features, which comes out at around about $5 a month. Those subscriptions help keep Ground News ad-free and therefore free of any bias that comes with paid advertising. So a big thanks to Ground News again for sponsoring this video, and now let's get back to talking about Comet 3I Atlas. Because it wasn't just NASA's fleet that we're observing it this month, it was also the ESA fleet too. So we heard heard last month about how ESA's Martian fleet also observed 3I Atlas as it swung past Mars in October, and we saw the images that were taken. But those observations then gave us a whole new viewing angle on the comet and its movement across the sky, which meant that in the past month, ESA was able to work out its orbit with much more accuracy, triangulating its position by combining it with Earth-based observations. It meant they were able to get a 10-fold leap in the accuracy on the orbit, reducing the uncertainty of Comet 3I Atlas's location and future position. That improved trajectory allows us to aim our telescopes and satellites with way more confidence, when we're trying to spot this faint blob, which allows for much more detailed observations. Like, for example, with the Hubble Space Telescope or ESA's JUICE mission, which is on its way to Jupiter, which also observed 3I Atlas with its scientific instruments and its guidance camera. Now, the data from the scientific instruments won't arrive on Earth until February 2026 because the main antenna on JUICE is currently being used as a heat shield. And so we're only getting a very weak signal from a smaller antenna right now. But the JUICE team decided to actually try downloading just a section of a single exposure on the very low resolution navigation camera image to see what they'd actually managed to capture. And so here is that little section of the image they downloaded. It was great to see that there's actually very clearly a visible comet in the image, first of all, but it's also surrounded by signs of comet activity, right? It has two tails. It has a typical comet plasma tail made up of the electrically charged gas that stretches out towards the top of the image. And then you can also, maybe if you squint, see a little bit of a fainter dust tail, which is made up of just sort of the tiny solid particles of rock and ice that come off the comet, and that's stretching towards the sort of lower left of the image. Once we get that main science data packet back in February, we should see much clearer signs of this activity. So we'll have an image from the much higher resolution science camera on board JUICE, plus all the spectroscopic data so we can tell about the comet's composition. This was actually the first proper test of JUICE's instruments for the first time as well. So it's really exciting to get a hint of what they'll eventually be able to do around Jupiter when it arrives there in about 5 years' time. Moving on from 3I Atlas now, though, let's see what JWST has been up to, because we had two most distant thing ever seen discoveries announced this month that used JWST. First, this research paper from Jane and Wadadekar finding one of the most distant spiral galaxies ever spotted with JWST, and then this paper by Levin and collaborators who observed the most distant supernova that's ever been spotted. Now, yes, having these milestones of the most distant or the biggest or whatever are always exciting, but the reason why we care so much about spotting ever distant objects is because we're seeing them as they were when the universe was much younger. Because light takes time to travel to us, the more distant an object, the longer the light has been traveling through the universe. So really, we're not just seeing the most distant known objects, but also the earliest known objects. And by directly comparing them to closer or later objects, we can learn about how the universe has changed and evolved within that time. And thanks to JWST, we're now able to do that over tens of billions of years. So this paper by Jane and Wadadekar spotted a spiral galaxy where the light had been redshifted by a factor of about 4. That's how much it's been stretched by the expansion of the universe. And that tells us that the light has been traveling through the expanding universe for 12.3 billion years. So we're seeing this galaxy as it was when the universe was just 1.5 billion years old, meaning the universe had to have cooled down enough to allow spiral shapes in galaxies to form in that time frame. I've spoken about this before on my channel when I covered my own research into this with JWST and in a video on why we don't really understand spiral galaxies yet. So I'll link both of those below if you want to check them out. Then in this paper from Levin and collaborators, they've observed a supernova with JWST that's at a redshift factor of 7.3, meaning its light has been traveling for just over 13 billion years. And so we're seeing a star run out of fuel and implode and explode when the universe was only 700 million years old. This particular supernova was originally spotted in March 2025 by the SVOM gamma ray satellite, and the high energy bursts of gamma rays and X-rays that come from supernova really only last a very short time. So an hour and a half after it was first spotted, NASA's SWIFT observatory managed to pinpoint the X-rays source's location on the sky. And then within 24 hours of that initial gamma ray burst being detected, the Very Large Telescope in Chile managed to observe it and also get the first estimate of the supernova's distance. That was when Levin and collaborators applied to use JWST to observe this as part of its director's discretionary time. It's used for things that crop up like this, like supernova or Comet 3I Atlas that are a bit unexpected. And they finally managed to use JWST to observe this supernova 110 days after the gamma ray burst was initially detected, to observe like the post-supernova, post-burst infrared glow. And what's really interesting is that Levin and collaborators found that this supernova is not really any different from local like benchmark supernova afterglows. So despite the very different conditions that we think were in the early universe at that time, the star that died and went supernova won't have been much different from those that we see today. And so knowing this helps us piece together our picture of the early universe, including how all the heavier elements that are dispersed thanks to supernova get mixed in over billions of years so that eventually planet systems like ours could form. And finally, let's talk about this research from my colleagues here in Oxford. Tudorache and collaborators have claimed to have found the largest rotating structure known in the entire universe. So, what they were looking at were observations taken using the South African Meerkat radio telescope, which is able to detect the light from hydrogen gas in the universe, which has the potential to be used for future star formation. And they found within that data 14 galaxies that formed a long, thin structure around about 5.5 million light years long. And that really piqued their interest, because they then realized that these galaxies are actually just one part of a much larger cosmic web filament that's traced by galaxies that have originally been detected with our visible light telescope. And this filament spans nearly 5 million light years. These filaments are the largest structures in the universe, sort of like big, long roads that connect galaxies with gas and dark matter flowing along them. Together, the filaments make up what's known as the cosmic web. Now, we see this web forming from fluctuations in the early universe in simulations that we run with our computers. We watch it form as gravity slowly clumps denser areas together. And we see it when we plot out the 3D positions of galaxies observed in surveys that we've done of the sky with our telescope. The cosmic web just really clearly pops out. Now, while the knowledge of these filaments is not necessarily new, what's interesting in this research from Tudorache and collaborators was that from their radio observations, they could trace the hydrogen gas spinning in the galaxies in the filament. That's what these colored boxes show in this plot. The blue is the regions where the gas is coming towards us, and the red is where the gas is moving away from us as the gas rotates around the center of the galaxy. That means we then know the spin axis around which each galaxy rotates. Now, simulations predict that the spin of a galaxy should be completely random unless there's some outside force that influences it. Like, for example, if there's gas flowing from the filament into the galaxy, that would then preferentially align the galaxies to the gas flow along the filaments, at least to a certain degree. And you can kind of sort of see that happening if you just look by eye at the direction the arrows denoting the spin axis in this plot are facing, compared to like the purple shaded area marking the filament location and direction. But some quick statistics also shows how the average alignment here is around 0.75 for the 14 radio observed galaxies that Tudorache and collaborators found, and it's about 0.64 for the visibly observed galaxies along the filament, where you've made a guess at the rotation axis from the shape because you don't actually have any gas data on them. Now, simulations predict that the average alignment should only be around 0.5, so there could be something very interesting going on here. But Tudorache and collaborators also looked at the relative velocity of the galaxies with respect to the filament itself. That's what's shown in this plot. The position of each galaxy is colored by its relative velocity. Again, with blue showing galaxies that are moving towards us compared to the overall filament, and red colors denoting galaxies that are moving away from us compared to the overall filament's velocity. And even by eye, you can see, right, there's some rotation of the whole filament going on there. But again, it's much easier to see when Tudorache and collaborators fit to this data to reveal the rotation of the filament itself is around about 110 kilometers a second, making it the longest and largest spinning structure ever discovered at 50 million light years long. And that is another big challenge to our current models of galaxy evolution. And it suggests that the cosmic web and its filaments might influence galaxy rotation and evolution more strongly or for longer than previously thought. And this will be a big question for teams working with the survey data from the likes of the Euclid Space Telescope and from the Rubin Observatory in the next few years to come. All right, that's it for Night Sky News for this month and for this year. It has been 7 years of me making Night Sky News on YouTube, and I am still so grateful for each and every one of you that continues to tune in every single month just to chat space with me. I'm especially grateful this year, which has been an incredibly difficult year for me and my family. Thank you again for all of your well wishes after my breast cancer diagnosis. I am almost at the end of my adjuvant chemotherapy treatment. And while I've been signed off my university research work during that time, being able to make the odd video here and there for you has just brought this sense of normalcy and joy that, again, I just cannot thank you all enough for, that I get to do this as part of my job. You might have noticed that the videos that I have posted in the past couple of months have mostly been done using voiceover, just to make that whole process a little bit easier on me as I was going through treatment. So for example, the intros and outros of October and November's Night Sky News were all filmed in advance of me starting chemotherapy back in September. So this is actually the first time that I've been on camera and even done a full face of makeup in about 3 months, and it feels good. I am hopeful for my hair. The kohl cap, despite being very painful, seems to be doing its job in the places where you can see that it's actually made contact. So keep your fingers crossed that it continues to do so throughout the rest of my treatment. Radiotherapy is the next step for me in January. And after that, I'm hoping to get back into my research and hit the ground running with making videos and content for you all in the new year. And I'm so looking forward to it. So all that's left for me to say is that I hope you have a very Merry Christmas, or if you don't celebrate, just a restful Betwixtmas and New Year period. But most importantly, until next time, everybody, happy stargazing.